Hi, this is Aramboy once again, and welcome to another episode of my lecture series in differential equations. In the previous video, we learned how to solve first-order differential equations with homogeneous coefficients. And now, in this episode, we will learn how to solve a new type of first-order equation which are called exact differential equation. But when is a differential equation said to be exact? So let's find out the answer as we begin our discussion for this topic on the next slide. The first order differential equation in the form, so we may recall that this form is the differential form of a first order equation. So when is this differential equation said to be exact? So there is what you call the test for exactness. If you recall the topic about partial derivatives in differential calculus, it will be very useful in this topic because we will be using partial derivatives to determine if a first order equation is exact or not. So, paano ito ginagawa? Simple lang. Itong multiplier ng dx, kukunan mo lang siya ng partial derivative. But not with respect to x. Kaya nga dx, hindi with respect to x. So, you will get the partial derivative of m with respect to y. Again, if its multiplier is dx, dapat hindi with respect to x. So, it should be with respect to y. And for this term, since its multiplier is dy, kapag kinuha mo ang partial derivative niya, dapat hindi with respect to y. Okay, so it should be with respect to x. Now, if their partial derivatives are equal, then the differential equation is said to be exact. So once again, the first order differential equation in this form, which is called the differential form, is exact if and only if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. So here, m is the coefficient of dx and n is the coefficient of dy. So kung ang multiplier niya ay dx, pag kinuha mo ang partial derivative, dapat hindi with respect to x. Kaya nga, ayan, with respect to y. At kung ang multiplier niya naman ay dy, dapat pag kinuha mo ang kanyang partial derivative ay hindi with respect to y. Kaya nakalagay dito, with respect to x. So now, this is what we call the test for exactness. And once the test of exactness has been verified, and we learned that the given differential equation is exact, then pwede na natin siyang isolve. So ngayon, mag-practice muna tayo gamit ang partial derivatives kung paano ma-determine kung ang isang equation ay exact o hindi. So example, here we have x squared y dx plus x plus 2y dy equals 0. So ang una natin gagawin is to determine if this equation is exact or not. To do that, we need to use the test for exactness, which would require partial derivatives. So here, the multiplier of dx is x squared y. So if we get its partial derivative, it should be with respect to y, not with respect to x. So we will get the partial derivative of x squared y. Dahil ang multiplier ay dx, so dapat with respect to y. Now, if we get its partial derivative with respect to y, so here, x will be assumed as a constant. Okay, so here, our derivative, of course, is x squared. Kasi parang constant multiplier lang siya. Imagine, if x is a constant, para baka halimbawa 3 lang yan, 3y. Ano ba ang derivative ng 3y with respect to y? So, 3. So, ito na siya. And here, the multiplier of dy is x plus 2y. Okay, so we should get its partial derivative, the partial derivative of x plus 2y. But since its multiplier is dy, dapat pag kinuha mo ang partial derivative, dapat with respect to x. So the derivative with respect to x of x is 1. And since this is with respect to x, ang y ay ina-assume natin na constant. And since it's a constant, its derivative with respect to x is 0. So now, this tells us that the partial derivatives are not the same. This means that this equation is, okay, the DE is not exact. So let us see another example. This time, we have 3x squared y dx plus the quantity y plus x cubed dy. We will use the test for exactness to determine whether this equation is exact or not by getting the partial derivatives. So here, the multiplier is dx. That's why when we get its partial derivative, it should be with respect to y. So since that is with respect to y, x is assumed to be a constant. So here, our partial derivative is 3x squared. How about here? Since its multiplier is dy, we should get its partial derivative with respect to x. So, and assume that y is a constant. So, this will give us a 0 answer for the first term. And here, the derivative with respect to x is 3x squared. And yes, the two partial derivatives are the same. Therefore, this differential equation, or we can conclude that the DE is exact. O, diba? Ang dali lang. Madali lang siya. So now na marunong na tayong mag-determine kung exact ba ang isang DE or hindi, the next step is to obtain the general solution. So ngayon, paano ba kuhanin ang general solution ng isang exact differential equation? Simple lang yan. The general solution of an exact DE may be obtained as follows. Kulang siya ng M. So if you recall, the differential equation, we have M of x y dx plus n of x y dy equals 0. So to get the general solution, we just integrate both terms. So first, we'll integrate this. The integral of m of xy dx is equal to a certain f of x plus u of xy plus c. So here, take note that we are integrating with x. That means that in this expression, x is a variable. And because of that, y will be assumed as a constant. So pag nag-integrate ka, mahalaga yun ha. Since ang variable ay x, ititreat mo ang y na constant. So may makukuha ka dito na sagot purely in terms of x plus a certain function uxy na possibly combination ng x at y. And there are also some cases in which the term f of x becomes 0. So wala kang makikitang purely in terms of x. Now after integrating this part, we integrate the second part, this one. So when we integrate n of xy dy, we are now integrating with respect to y. So y here is the variable, and therefore when we integrate this expression, we will treat x as a constant. Again, that is because y is the variable of integration. Now we may get a function that is purely in terms of y and another term which is a combination of x and y. And then, of course, plus the arbitrary constant. And there are some cases in which the term g of y becomes 0 because it's nowhere to be found in the equation. And that's okay. So now the general solution can be obtained by adding f of x and this term g of y, and also you get the common term. Okay, so this u of xy is the term that is common to both answers. So that's u of xy, and then lagyan mo lang ng equals c. Okay, so this is now our general solution. So once again, to obtain the general solution of an exact differential equation, you add the terms f of x, g of y, and the common term and equate them to a certain arbitrary constant c. Okay, so there are times that f of x would be 0 or g of y would be 0, and sometimes f of x and g of y will be both 0, leaving us only with the term u of xy. Okay, simple lang, di ba? Ayan. So pawiin ko na yung sinulat ko para makita niya. Ayan, f of x plus g of y plus u of xy is equal to c. Okay? So, mag-solve na tayo ngayon ng mga examples. Number 1, solve the equation 3x squared y dx plus y plus x cubed dy equals 0. Now, ngayon, anong sunod na gagawin? I-integrate. So, i-integrate natin yan. 3x squared y dx. Okay. So here, the variable of integration is x. Kaya i-assume natin ang y ay constant. So, since constant siya, unahin na natin yon 3 times y. Tapos, ang i-integrate natin ay x squared. Na pag in-integrate mo, magiging x cube over 3. O, di ba? Lagyan mo lang ng plus c. And then, obviously, magka-cancel yung 3 dito at yung denominator na 3 doon. Leaving us with x cube y plus c. So, dito, yung term na purely in terms of x, wala. As we can see, x cube y lang yung sagot. Now, integrate naman natin itong pangalawa. The integral of y plus x cube dy equals, okay, so here, the variable is y, so that is why when I integrate, I will treat this x as a constant. Okay, so magiging y squared over 2 lang, itong first term, pag in-integrate ko, plus, since ito ay constant, magkakaroon lang siya ng multiplier na y. So, x cube y plus c. So, this is now the integral. Okay, so, let's now proceed to find the general solution. For the general solution, let us combine the term that is purely in terms of x, okay, which is nowhere to be found, absent siya. And then hanapin natin yung purely in terms of y. So ito yon. We have y squared over 2 plus, dapat may term na common sa kanilang dalawa. Ayan, no? X cube y, x cube y. So yun yung common term. X cube y at i-equate natin sa c. Okay? Para mas magandang tingnan yung ating general solution, we can multiply both sides of the equation by 2, no? To eliminate this denominator. And we will get y squared plus 2 x cube y equals, itong c, pag minultiply ko ng 2, arbitrary constant pa rin siya. Ayan, gawin na lang nating capital letter C. Okay, so this is now our general solution. O, diba? Ang dali lang. Let us solve another example. Solve the equation 2xy minus 3x squared dx plus the quantity x squared plus 2y dy equals 0. Okay, let us assume na exam ito. Siyempre sa exam, hindi naman binabanggit kung ang equation ay exact, homogeneous, or separable. Sa exam, ang nakalagay lang doon, o solve this DE. Okay? So kapag kaganyan, ang first instinct, dapat alamin mo, yan ba ay separable? So as we can see here, the multiplier of dx consists of two terms. Na yung isang term magkasama ang x at y. Okay? Dahil dyan hindi mo siya masa-separate, no? May minus o tapos magkasama yung x at y. Dito ganun din. Meron tayong x squared plus 2y. Yung addition dito ang dahilan kaya hindi mo siya masa-separate. Okay? So hindi siya separable. So the next thing is to test if the equation is homogeneous. Yung unang term 1 plus 1 2 ang exponent. Yung pangalawa 2 din, aba. Okay, yung pangatlo 2 din. Ay, shit. Yung last term, ang exponent niya 1 lang at wala siyang x. So here, the sum of exponents are 2, 2, 2, and 1. So hindi pare-parehas kasi yung last term, 1 lang ang sum ng exponent. So that means this is not homogeneous. Okay? So the equation is not separable. Also, its coefficients are not homogeneous. So, ang sunod mong gawin, test mo kung exact siya. O, diba? Okay, paano nga mag-test kung exact ang DE? Kunan mo siya ng partial derivative, dapat kung dx with respect to y. So, ano ang partial derivative niyan with respect to y? So, that's 2x. Ito naman, kung with respect to y, 0. Kasi nga, we will treat x as a constant. Now, let us see if that would be equal to the partial derivative of this term. So, since ang multiplier ay dy, dapat kunan mo siya ng partial derivative with respect to x. So, may makukuha tayong 2x. And, since here we will treat y as a constant, 0 na yun. Kaya, ay, 2x nag-equal sa 2x. So, that means that the DE is exact. Yes. Again, example siya for exact DE. But we are, of course, imagining a situation just like in the examination, kung saan hindi naman naka-specify kung exact ba homogeneous or separable ang D. So, ganun ang ginagawa. Ngayon, alam na natin na exact siya. Anong sunod na gagawin? I-integrate the integral of 2x y minus 3x squared dx. So, here, our variable is x because we have the differential of x. So, we'll treat y as a constant when we integrate. So, we have 2y and then i-integrate mo yung x, magiging x squared over 2 minus 3x squared. Pag in-integrate, magiging 3x cubed over 3 plus c. So, there, may makakancel na mga terms. Kagaya nito, makakancel siya, pati ito, leaving us with x squared y minus x cubed plus c. Now, let's integrate the second part here, n of y dy. The integral of x squared plus 2y dy. Here, the variable is y because we have the differential of y. And thus, we will treat x whenever we integrate as a constant. So, pag integrate mo yan, yung x squared na yan, makakaroon lang siya ng multiplier na y. At ito naman, magiging y squared over 2 plus c. Ay, shit, nakalimutan kong ilagay yung 2. So, now, yung 2 na yan, makakancel siya. Ayan, nag-cancel na siya. No? And let us rewrite the simplified answer here. X squared y plus y squared plus c. Now, we are ready to write down our general solution. Okay? What is now the general solution of this differential equation? Hanapin mo yung term na purely in terms of x. Ito siya. Pero negative, no? Kaya, pangit tingnan kung siya yung nasa unahan. So, gawin natin ito yung nasa unahan, y squared. Okay? And then minus x cubed. Tapos, hanapin mo yung term na common sa dalawa. Alin yung common sa kanila? Ayan, no? X squared y plus x squared y. And then, lagyan mo lang ng equal c. Okay? Di ba ang dali? Ito na ngayon ang ating general solution. O, di ba? Ang dali lang. Napakasimple. Sobrang dali. O, dahil madali, isa pa. Let us solve. This time, let's solve an equation involving trigonometric functions. Cosine x, cosine y, minus cotangent of x, and then dx minus sine x, sine y, dy. So, ganun ulit ang ating gagawin. Ano? Magte-test muna tayo for exactness to ensure that the differential equation is indeed exact. So, let us get the partial derivative of this with respect to y. Cosine x will be assumed as a constant. And then the derivative of cosine y is negative sine y. And then, since cotangent of x is assumed to be a constant, its derivative would be 0. Now, let us see if that would be equal to the partial derivative of this term with respect naman sa x. Kasi dy yung multiplier niya eh. And negative siya, no? Negative. So, if that is with respect to x, dapat yung sine y, constant multiplier na lang. Tapos, ano ang derivative ng sine x? Diba? That's cosine x. Ay, equal ba sila? Yes. They are the same. Bakit? Kasi ayan, no? Negative of cosine x, may cosine x, sine y, may sine y. So, that means this equation is exact. Our next step is to integrate. Ayan. O, integrate natin to. Yang lahat ng yan. Cos x, cos z, cos y, minus, nahuli mo yung x mo. Bakit? Ayan, no? Because you caught your x. Ay, charot. Dx. And, here, our variable is x. That is why we will treat cosine y as a constant. So, magiging cosine of y. Pag in-integrate natin ang cosine x, ang sagot ay positive sine of x. And then, what is the integral of cotangent x? That's ln of sine x. Ayan. So, dito ko na lang ilagay sa taas yung plus c. Now, let's integrate the other one. Pangit mo integral ko. Parang ikaw. Ay! The integral of, ayan, negative sign. Baka makalimutan mo. Negative sin x sin y. Makintab yan. Why? Because it's siny. dy. So, if we integrate this, we will treat x as a constant. So, sin x here would be a constant multiplier, no? And then, i-integrate mo yung sin y. Di ba pag in-integrate natin ang sin, negative cosine ang sagot. So, negative cosine of y and then plus c. Okay, so simplifying this, we'll get positive. Sin x cosine y plus c. Now, let us write down the general solution. Meron bang purely in terms of x? Ayun, kaso nga lang minus siya, di ba? So, unahin na lang natin yung isa. Walang purely in terms of y. So, ang meron tayo is yung common term, cosine y sin x. Ayun o, cosine y sin x. So, unahin na lang natin yan. Sin x, cosine y, minus ln of the absolute value of sin x equals the arbitrary constant c. So, since may ln tayo dito, gawin na lang natin siyang ln of c. Para pwede nating pagsamahin ang dalawang terms na iyan kasi parehas silang may ln. Ano? So, I can rewrite this as sine of x and then cosine of y equals, yan. Pag ito nilipat ko sa kabila, ln of this plus ln of c. Pwede ko na silang pagsamahin gamit ang isang ln. So that would become ln of c times the sine of x. Okay? So this is now my general solution. O, diba? Ang dali lang. Sobrang dali. Pangit naman ng initial ko. Ito siya. Yan. Ayaw. Charot. Okay, let's solve another example. Solve 2xy minus tangent of y dx plus x squared minus x times secant squared y dy. Okay, so this time, hindi na muna tayo magte-test for exactness. Assuming marunong na tayong kumuha ng partial derivative. Dahil alam na natin, halimbawa, nakapag-test for exactness na tayo kasi, sige, gawin nyo na lang exercise yan. Practice exercise. You have to prove that this equation is exact. Okay? Now, let us solve na. To solve that, we integrate this term 2xy minus si Tani dx equals. So, remember, kapag ka nag-i-integrate ka na ang variable ay x, you should treat y as a constant. We will get here 2y, constant na siya. Tapos integrate mo tong x. Eh, di ba magiging x squared lang siya? X squared over 2. O, di ba? And then, makakancel sa kanya yung 2. Ayan, makakancel to. Ay, huwag mo kalimutan yung term na yan. Minus the integral of tangent of y. However, this is dx. So, there's no need for us to integrate tangent of y because here, we will treat y as a constant. So, kung constant lang yan, tapos meron kang dx dito, lalagyan mo lang yan ng multiplier na x. So, minus x tangent y, and then yung arbitrary constant natin na plus c. Diba? Simple lang. O ngayon, rewrite natin tong buong to. So, magiging x squared y minus x tangent y plus c. Let's now integrate this term, x squared minus x secant squared y dy. Take note, our variable is y, so we will treat x as a constant. So this x squared will just have a multiplier of y pag in-integrate mo, and then minus, again here, x is a constant. Tapos ang i-integrate natin is yung secant squared. Ano ba ang integral ng secant squared y? Di ba tangent yan? Tangent of y. Bakit? Kasi ang derivative ng tangent ay secant squared and then plus c. Okay? Shit! Napansin mo na parehas lang sila exactly? So, wala kang term na purely in terms of x. Anyway, since exactly the same sila, madali lang yung general solution natin. Yung common term lahat kasi wala namang iba eh. So, the general solution is now x squared y minus x tangent y is equal to c. O, di ba? Andali lang. Sobrang dali mag-solve ng mga exact DE. Promise. So, to conclude our discussion for today about exact differential equations, let us solve the last and final example. Solve the equation y prime equals this over that. Okay, so if you notice that the given differential equation is not in differential form but rather in the derivative form. So, ang gagawin natin is i-convert mo muna itong derivative form na ito into its corresponding differential form. 'Di ba dapat ang format niyan is m of xy dx plus n of xy dy equals 0. 'Di ba dapat ganyan yung form? So, unahin natin yung may multiplier na dx. So, di ba ito dy over dx yan? So, yung dx sa baba at saka ito, i-multiply ko lang. So, yun yung mdx ko. So, I have 2 plus y e to the xy dx equals, ito yung dy na matitira dito, multiply ko lang dito, yun na yung ndy. So, we will have 2y minus x e to the xy dy. Okay, so is this now the differential equation in its differential form? Okay, hindi pa rin. Bakit? Kasi nga po, dapat naka-equate yan sa 0. Magkasama yung m dx at saka n dy doon sa left side. So, ang gawin mo, ito ilipat mo lang sa kabila. Ano? So, rewrite lang natin siya. Rewrite lang natin na magkasama yung m dx at n dy sa kaliwa at naka-equate sila sa 0. So, this becomes 2 plus y e to the xy dx plus, so ito, pag nilipat ko sa kabila, magiging positive yung sign niya. So, x e to the xy, tapos ito naman magiging minus pag nilipat sa kabila. Minus 2y dy, ayan, is equal to 0. So, ito na ngayon yung mdx plus ndy natin. So, exercise na lang, no, ang pagpuprove na ito ay exact. Of course, this is exact kasi example siya ng exact DE, di ba? Again, exercise na lang 'yon. So, i-solve na lang natin, ano? Paano nga mag-solve? Dapat i-integrate mo yung mdx. So, 2 plus y times e raised to xy dx. Okay. So, dito, ang variable ay x, we will treat y as a constant. Okay, integrating, I will have 2x plus, itong y na to, constant lang yan. So, eto na siya. And then, ito i-integrate mo, e to the xy. Kung saan yung y ay treated as a constant. So, para bagang e to the 2x. Diba? So, diba pag integrate mo yung e to the 2x, magiging e to the 2x over 2. Diba? Kung ano yung multiplier ng variable, naging denominator lang yun. Diba? So, that's e to the xy divided by yung constant multiplier dito. Alin ba ang constant? Yung y. So, over y. Ayan. And then, plus c. So, itong y mawawala kasi magka-cancel siya. Cancel natin yan. At ang matitirang sagot is 2x plus e raised to xy plus c. Diba? Dali lang. I-integrate natin yung n dy. Ito yun. So, x e to the xy minus 2y. Ay, dy equals, okay. So, here, y is the variable. And when we integrate, we will treat x as a constant. So, constant lang daw ang x. So, multiplier na lang siya. Tapos dito, ang x ay constant. Di ba pag nag-integrate tayo ng exponential, kung saan ang exponent ay may constant at may variable, yung variable niya na multiplier ay nagiging denominator. So, e to the xy over x. Ayan. Minus, ito naman magiging 2y squared over 2. Ay! May mga magka-cancel uli. I-cancel natin yan. The cancel culture. So, yung cancel culture, dito ina-apply sa differential equations para maging simpler yung expression mo. So, in differential equations, we apply the cancel culture. So, dito ang matitira is e to the xy minus y squared plus c. So, we are now ready to find the general solution. So, the general solution is now, nasan yung term na purely x? Ito siya. 2x. and then get the term that is purely in terms of y. Ayan, negative y squared. And then yung term na common sa kanilang dalawa, which is e to the xy. At i-equate mo lang siya sa c. And there you go. This is now our general solution. O, di ba? Ang dali lang. Sobrang dali. Okay. So, ngayong nalaman na natin kung gaano kadali mag-solve ng mga exact differential equations, sa susunod na episode, ang topic naman natin is paano kapag ang differential equation ay non-exact. So, kung non-exact siya, gagawin natin siyang exact. Saka natin siya isosolve. And I will teach you that topic in our next episode. Okay? So that would be all for the moment. Bye!